Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is walls and gates. So let's go to this problem. Exactly, it's a premium problem. That means we can't access it on LeetCode, but we're going to solve it on iPad. That's where we'll be writing the code. So it's important that we understand the solution. We don't really have to test it, but as long as we can do the dry run and test some example cases, then we should be good, right? Okay. So the problem is walls and gates. You are given m cross n grid rooms initialized with these three possible values. So these grids, basically this is a m cross n grid, and these are rooms. So these are rooms right here, and these are initialized with three different values. What are those three different values? Well, there is -1, which is a wall, or basically a wall or obstacle. So, and then 0. So I'm just going to write these values right here. So this is -1, this is -1, -1. So these are the walls. And now what is our second value? That is a gate, and that has been initialized with 0. So this is a 0, this is a 0. So there are two gates in this particular grid. How about the third value? This is an infinity value. It's infinite value. That the value is basically 2147483647. That's it's representing the infinite value. Now what do we have to with this infinity? Well, this also represents the distance right now to any of these gates. What we need to do is fill these empty rooms. These are the empty rooms. Okay, probably I should have written it like this. These are the empty rooms initially having the value infinity. Okay, these are the values. Now what do we need to do? Fill empty rooms with the distance to its nearest gate. If possible to reach gate, it should be filled with. If it's impossible to reach the gate, then it should be filled with infinity. Well, what's already the value infinity is present. We just need to fill the minimum distance to these gates from each of these rooms or this cell to their nearest gate. Okay, so how are we going to do it? Well, let's say so in this case there are two ways of filling these grid. First is DFS and another is BFS. Now in this particular case, like most of the problems, if we can do it with DFS, then we can definitely do it with BFS as well. And in this case, we can solve the problem with using both methods. But what I think would be really good or more efficient would be a BFS, breadth first search. Why? Breadth first search uses queue, and then we have this initial node or this initial cell that we begin our traversal with. In this case, it will be our gates. And then we're gonna start exploring the connected nodes to these gates. So what are the connected nodes right now? If you imagine, the connected node to this gate is right here, and connected node to this gate is right here. But if we were to basically start our BFS with two initial nodes, then it would also be starting with this particular gate as well. So together we have these two initial nodes that we begin our BFS with. So we have these two nodes. So let's say initially what will be happening is we'll have a queue in BFS. We'll have a queue. Initially that queue will have these two nodes, which are gates, and their value is right now 0. So if we basically put the indexing here, so it's 0, 0, 1, 2, 3, 0, 1, 2, and 3. So what are the address of these gates? It's 0, 0, 0, 2, and then another gate is 3, 3, 0. All right, so these are basically our initial nodes to begin our traversal with BFS. So there are two things that we are going to do here. First is explore its each of these initial nodes neighbors, because they are gates right now, and the distance right now is 0. So the distance right now is 0, because the distance of gate to itself is 0. Then we're gonna start basically a while loop. We'll have a while loop while q is not empty. So while q is not empty, then what we're gonna do, all of these nodes that you're seeing, they are at the same level, so they are going to be assigned the same distance. What is our distance right now? It's 0. Initially it's like already 0, but like we are going to, for the sake of this algorithm, we are going to assign this so that we see what we are actually doing. So what's going to happen is, I want to take out all of these nodes at same level and store it into a different queue. So I'm going to call it, let's say this queue. Okay, and I'm going to basically assigning this queue to all the values, and then this queue is going to be now empty. This is going to be an empty queue now. But here, this empty queue, we will basically add all the valid cells, which we will fill right now, so that they can be explored on the next level. So what I'm going to do now, I'm going to explore all the nodes of this particular queue. So I'll do for node in queue. So this queue has all these nodes right now. These nodes are in this queue right now because we have assigned it right here, and we are exploring both of these nodes right now in this particular level. So I will access my node, and this is basically the address. So I'm gonna access it using RNC, and then node. Okay, node. So these are the address of these are the address of that node. Now what I want to do, first of all, I have this distance right here, so I want to assign the distance to this particular node. What is the distance? Distance is right now 0, so I won't write 0 because we are writing a generic function. So I'll be basically adding that distance to this particular grid. So I will have grid at R and C. This will be getting assigned distance. Now we have assigned this distance right here. What are we going to do now? So we are going to explore the neighbors of this particular node. So right now the node that we are exploring, let's say for now I'm exploring this node, although I will be exploring on the same level, that will be getting assigned the distance 0 as well. But right now, let's say I'm exploring 0, 2. That means I'm exploring this particular node I'm exploring. So what I would want to do is, I want to check its valid cells. So this way, these are like all the neighbors of this gate, but these are not valid because this is an obstacle, this is out of bound, this is a valid cell, this is a valid cell or valid neighbor cell. So what I'll be doing here is, I'm gonna have like this helper function to check valid cells, and then append that valid cell to this particular queue, so that those valid cells could be explored on the next level, right? So what I'm going to do is, now I will have this helper function created somewhere. Let's say at this point there is no point of having this. Great. So what I'm going to do here is have this helper function, and I will basically be best. The placement is this is okay. So what I'll do now is have this helper function. First, I want to explore its basically its neighbors. So what are the neighbors of this particular cell? Well, those are going to be left, right, this is right, left, top, and bottom. So I will have this helper function. Let's call it add valid cells. So we're gonna call it add valid cell. So R and C. Okay, R and C. And it's not like I'm not adding these valid cells, I'm just adding these valid cells to basically my queue, because I cannot add the obstacles. Well, we already discussed, there are this particular gate has basically four neighbors. This we cannot add, it's like the obstacle. This is out of bound, so there are only two valid cells that are this gate's neighbor, so I will append those two to this queue. So here I will have basically all those conditions. If this R is less than 0, C is less than 0, C is equals to, let's say, if the number of rows and columns is R and C, and there is a visit set as well. That will keep track of the gates that have already been visited. So if C is equals to this big C, and R is basically equals to this big R, number of rows, so it could go out of bound, or this combination of this, basically this address is in visit. That's also when I don't want to visit it. And then there's one more thing. What is it? If that cell is an obstacle. So if grid, so let me move this here, move this down. So if grid at R and C is equals to -1. So if any of this case is happening, happens, then I will be basically returning from here. I will not be adding this to my queue, so then return. Otherwise what I'll do is I will add this to my visit set, this particular visit dot add this R and C that is added, and also I will now also append that to my queue. So my queue, I will declare that queue like somewhere outside, so queue dot append, that will be accessible like to this inner function as well. So queue dot append this R and C, right? This is my helper function now, but this here we have not completed this one. So what was happening here for this particular node, I have to explore its neighbors. So what I'll do is I will have this function called add valid cells. So I will just copy this and then paste it here. No, I can't. Well, anyway, I'll just write it down. So add valid cell, then R plus 1 C, then I will do add valid cell R minus 1 C. So I'm just like trying to add these neighbors and calling this helper function. So if those are valid neighbors, then they will be added and added to visit set. Otherwise we will just return from there, do not do anything. And also have, explore sideways for columns. So side neighbors, basically left and right cell. So you'll be changing the column for them, C plus 1, and then add valid cell for row remains same, C minus 1. So now these have been added. Now there is one more thing, because at this particular level we were exploring all using this for loop, we were exploring all the nodes and their neighbors that were on the same level. But once we come out of this level and we have added all the neighbors at this particular position, we will be incrementing our distance, because I will just tell you right now. So distance will be incremented by 1, and then finally we can just, like in the end, return the grid, return just grid. So we just return grid. Like after you fill this up, this is what you return. So what must have happened if you do the dry run, what must have happened is initially my queue is going to have these two gates. So these two gates placed already, they have been added right here, these two gates. Then let me do the numbering again. So 0 1 2 3 0 1 2 3. So I've already added these two gates, so we're gonna have the distance 0. we're gonna have the distance 0. Then we start exploring. If the queue is not empty, queue has been loaded into this new queue so that I can explore all the nodes in this new queue at the same level. Then I take out its basically indexes. Then I assign that distance to that particular address, and the distance, it starts with 0 because we are starting those with the gates. Then I'm going to add all the valid cells to my neighbors. This is the valid function. We have already been through it. Now what will happen is this will call all its neighbors. So let's go over just one of the gates. Let's say this time let's go over this gate. Let's go over this gate. So this is 3. So it's going to check all these neighbors. So these two are not valid because of their out of bounds. This one is not valid because of -1, but this one will pass and it will be added to my visit, and then it will be added to my queue. So now queue, this new queue right here, will have one more node that will be explored on the next level, and that will be 2, 0. So this will be the next node, and these two will be coming from the other gate. So those will be 0, 3, and then 1, 2. So there will be these 3 nodes that will be explored on the next level. So right now this will be assigned the value 0, these will be 0, and the next we will be exploring this one and this one and this one, and right now the distance has become now 1 because we have incremented the distance right here. And then we will be when we'll be exploring these, so we'll assign the distance 1, and then explore their neighbors. So this is a valid neighbor, this is a valid neighbor, this is a valid neighbor, these three, and then those 3 valid cells will be explored in the next iteration. So now I would say the time complexity of this particular solution is while we are exploring this. So at most I think we'll be covering all the nodes. So the time complexity would be is going to be big of n cross m, and then space complexity is also going to be big of n into m, because worst case, let's say all of them are gates, so we'll have to add them to our queue. And remember, this particular step will be performed using a for loop, going over basically 2 for loops, nested for loops, and visiting all the cells and checking if that's a gate, then append it to my queue, and then you start basically this particular function, which calls this inner function. You can write it anywhere, or external function, wherever you want to write it. I know it looks a little messy, but if you were following me, I think I have tried my best to explain this, and I think that's the best we can do, since we can't really go write the code on LeetCode. It's a premium problem. But anyway, what we're gonna do is we're gonna go back to AlgoYogi, and mark this problem solved, because we have solved it, and see you guys in the next problem. At least next time we'll be able to access those problems. Bye bye.